Hi everybody, welcome to the Mathematical CPD Library. Today we're going to be looking at arc lengths and sectors. Now, if I wanted to start by finding the area of a sector, I need to remind myself that it's actually part of a circle, and therefore the formula pi r squared must be relevant somehow. What I need to work out is, where's the radius? Now, in this diagram, the radius will be here. You could always draw the full circle on your whiteboard to demonstrate that to students. So I know that this sector is going to have something to do with pi times by 2.5 squared. The issue here is that I don't have a full circle, I've just got a fraction of it, and the fraction I've got is 80 out of 360 degrees. So I'm going to adapt this formula and I'm going to add the fraction that I have at the beginning. So 80 over 360 multiplied by the full area should give me the area of the sector. If you then type that into a calculator, you would get 4.4, which I have rounded here, centimetres squared. Now let's look at arc length. Now, the arc length is just this little bit here. It's the proportion of the circumference that you have. Now, I'm going to use the 2 pi r formula for circumference as opposed to pi d, but you can use either one. So here I can see that the radius is 3.4. Again, you can draw a full circle to see that if it would help. So I can say that really I need to use 2 times by pi times by 3.4 as part of my working out in this question. Now, I don't have a full circle here, and that's what 2 times by pi times by 3.4 would work out. I've got a proportion of it. Now, the proportion that I have is I've got 21 degrees out of 360. So I can add that to the beginning of my formula to work out what I actually have in this question. And if you type that in and round it, you will get 1.2, in this case centimetres, because arc length is a unit of measure. Moving on to something a little bit more challenging. If you want to calculate the perimeter of something, that means you want the full outside of the shape with arcs and straight lines included. So a good way to think of this is arc length is curvy, it's circumference. Circumference is a curvy perimeter. Perimeter includes potentially everything in a question. So what we're actually working out here is we're going to work out this full arc length, and then we're going to work out these two extra little bits that join together. So once you've realized that's what you need to do, the formula 2 times by pi times by r is still going to be relevant here. However, when we have finished that part of the working, we need to add on the 6 and the 6 to get the full thing. Now, I'll just add the 6 and the 6 at the end right now so that we don't forget later. Now, this question is a little bit tricky for a couple of reasons. The first reason is this 55 is not helpful to calculate the arc length because the 55 is this section here. What we need to find is this angle. So we would do 360, take away 55 is 305 degrees. So I now know I have 305 degrees out of 360. I can then use the formula as I would before. So 305 divided by 360 times by 2 times by pi times by the radius of 6, which is much clearer to see in this example, would give me 63.8. Now that is the value of the curvy arc length part of the question, so that is in centimetres. I just need to remember for perimeter, I need to add the extra 12 on the end, which would give me a total answer of 75.8, and I'm rounding to one decimal place here. You could definitely round more accurately. Now, there are ways that you could add more extreme challenge in questions like this, and I'm just going to look at two. So the first question gives you the answer for the area, and you need to find a missing angle. Now, in a question like this, you need to start by writing down what you know. So I know the area is 10. I know I've got x out of 360 degrees. I'm just not quite sure what that is. and I know I would times by pi times by 3 squared to work out the area. I'm then simply going to work through what I can work out. So I can do pi times by 3 squared, but that's the only thing I can do to start with. Now pi times by 3 squared is 28.26. I know that the answer still needs to be multiplied by x divided by 360, so I'll write that down. From there, I just need to use my solving equations knowledge, so I'm going to bring the 360 up and multiply it by 10, because right now this means divide by 360. So that would give me 3,600 equals 28.26x. I can then simply divide 3,600 by 28.26, and I would get an answer of 127.4 degrees. This diagram is certainly not drawn accurately for that to be the right answer, and you might need to point that out to students. Another quite common question is to find the shaded area where there are actually two sectors to look at. So if I look at the large sector first, I would say that I have 40 degrees out of 360, and I'm multiplying that by pi times by 7 squared. That would give me 17.1 as a very rounded answer. I can then do exactly the same with this smaller white sector. Again, it's 40 out of 360, but this time times by pi times by 3 squared, which would give me 3.1. Your answers could be more accurate than this. To get the shaded area, I'm then just going to take the little area away from the big area to get an answer of 14 centimetres squared. Now it's time for your checkpoint questions. So if you'd like to freeze the screen and have a go, I'm going to go over the answers in just a moment. So for question 1, you would need to do 50 divided by 360 multiplied by pi times by 3 squared, giving you an answer of 3.9 centimetres squared rounded. To calculate the perimeter, you would start by working out the missing angle in this sector. So 360 take away 70 is 290 degrees. You would then say you have got 290 divided by 360 multiplied by 2 times by pi times by 2.5. Now that is enough to get me the arc length of the sector. That's the curvy bit, but it isn't giving me the perimeter, because for the perimeter you need the whole thing. That means in this case you would also need to include the two straight lines, which are 2.5 and 2.5. If you then type all of that into a calculator and remember to add the 5 at the end, you would get an answer of 17.6 centimetres. Thank you so much for joining me for this tutorial. Here are your references.